Good morning. Welcome to the Nation in Conversation. You're joining us for a panel discussion on French and South African views on irrigation technologies and drought management. I'm joined by a strong panel today. And as a starting point for our conversation, drought has become a more prevalent issue for agriculture, not only in South Africa but in the rest of the world as well. And the management and efficient use of water is critical to manage climate change and the pressure on water resources. I'd like to welcome our panel and ask him to briefly introduce himself. Bruno, if you could please start and introduce yourself.
Okay. I am Bruno Moll from France. I am working in a research institute whose name is IRSTEA, is something equivalent to the IRC Felix is representing. Working on irrigation, both side technology and practices in the sense that we have a laboratory in which we evaluate the performance of the systems and that allow us to develop research and development from what we see from the testing. And the other side of our activity is more related to the practices of irrigation in the sense that we develop a crop model, and this crop model needs a number of data to be calibrated in order to be able to optimize or to anticipate an optimization of irrigation application.
Thank you, Felix.
Good day, I'm Felix Reinders. I'm with the Agricultural Research Council, the Agricultural Engineering Institute, and we are mainly doing research and technology development on irrigation technologies, but also supervising the government of today and also assisting farmers in terms of utilizing the irrigation technology effectively.
Okay, Christopher.
Bonjour, is it Requier?
Requier.
Nice to meet you, Requier.
Nice to meet you.
My name is Chris Clark. I'm the head of Delta Drone South Africa, with our head office based in France, in Paris. We're predominantly a technology company, really about kind of taking advantage of this new sort of advent of drones and how we integrate that into agriculture. So we use a lot of exciting sort of sensors, and how does that play out in a practical sort of field of sort of the agriculture sort of industry. So I'm very excited. Thank you for having us.
Hi, I'm Tony Da Costa. I'm from a family operation. We're a farming operation just about 50 kilometers east of Johannesburg. It's a big farming operation. We cattle breed together with cattle feedlotting, but then we also do a lot of crop production, both in dryland and under irrigation, pivot irrigation. And we do follow a lot of conservation tillage practices, and we definitely like to look at water use technologies.
Thank you. Alfred.
Good day, I'm Alfred Andrach from Agrica. We're an irrigation company, the oldest and biggest irrigation company in South Africa. We have about 90 irrigation designers working for us, 28 branches across Southern Africa. And we specialize in all kinds of irrigation, turnkey projects from design, manufacturing, supply, and installation and after-sales service.
Thank you. I'd like to start off just in South Africa in terms of water management, and then Bruno, I'd like to get your views from the French perspective.
Thank you. Yes, the challenges are fairly big, especially the last couple of years with the drought that hit South Africa quite hard. We had the last drought in the early 80s when the dams was only about 35% full, and we reached a point in 2015, 2016 when the levels of the dams also dropped to as low as 52%. We experienced then some excellent rains during beginning of February, which then also augmented most of the dams in the northern parts of South Africa. At the present moment, the dams are at 80% full, and if you look at the Western Cape scenario, which is really in a desperate situation, where the dams are now at 16.9%, with the Theewaterskloof Dam, that is the biggest supply of water to the Western Cape, sitting at 11.6%. So the water situation there is really critical, and they experienced the last 3 years in a row below normal rainfall. So that impact, of course, first of all on the farming community, because their water is normally cut first, because the assurance of water supply to them is of much lower than for the domestic sector. So the challenges are huge, and therefore the farmers and the researchers and the suppliers of equipment have to provide the necessary information and technologies to make the best use of our scarce water source. So there are different research that's been conducted. There are different ways our farmers are operating. And of course, there's also a shift in terms of the type of irrigation systems that the farmers are utilizing. We have seen the past couple of years a shift towards more drip irrigation in many parts. Flood irrigation was at first fairly big in South Africa. At the present moment, according to our statistics, is only 14%, where drip irrigation increased to 26% of usage of the 1.3 million hectares that are being irrigated in South Africa.
Okay, thank you. Bruno?
Well, I would speak about the challenge, I would say, more generally speaking than especially South African case, because I don't know as you in detail the specific case. I think that we are really entering now in the hard stuff of the climate change, and we are now facing really the deep, we are just entering in it, and now we are facing it concretely, I would say. In terms of symptoms of this climate change, we have two situations. One situation is the heterogeneity, the increasing heterogeneity of climate, whether it is on short terms or long terms, which will claim for different answers. On the long terms, of course, we have to think about increasing the capacity of storage. And on the short terms, that's really the role of irrigation technology to address this question. Well, that's what I would say in terms of challenge. And the view that we try to develop in our research center is we cannot solve or we cannot face this kind of problem in terms of disciplines or in terms of technology individually. I mean, if you try to address one aspect of performing or better performance of center pivots or drip irrigation or whatever, and you don't address in the meantime the water management issues, I mean, you will fail. So what we try in our research team, what we call the mixed research unit, is to try to address not only the technological aspect. I include the machines, the type of systems, the crop modeling and so on, but also to address the management way in terms of sociological aspect as well as the economical aspect. And so, and this is a trend that is really developing in Europe with the European Commission, which is supporting only projects which are multidisciplinary. That means that each time you apply for a research project, you always have a sociological aspect which is to be undertaken, including in most of the case policy making and so on. So this is the view that we are trying to develop in France, but not only in Europe, And I think this is one of the issues to address, or one of the points to work on.
Thank you. Alfred, a question to you. We're speaking about irrigation technology and water management, but could you perhaps take us through the distinction between just saving water and using irrigation efficiently?
Yes, I would say the first thing that you have to do is you have to select the appropriate irrigation type for the application. So you cannot say categorically that drip is the best irrigation system because you're using less water. Irrigation efficiency is far more important than exactly how much water you are using, because you should be measuring your yield in terms of the crop yield over the irrigation, the water that you are using for irrigation. And for different crops, you will have different systems that are ideal. So, for example, for wheat, maize, full surface irrigation, a center pivot would most probably be your most efficient way of irrigating because of high uniformities, better yields. If you are looking at row crops, you should look at micro and drip, depending on the surface area that you want to wet. Micro might wet a bigger area, whereas drip will wet a smaller area. So your soil type, the way that the water is distributed in the soil and reaches the roots of the plants, also the size of the root development that you are looking for plays a role, and obviously also the management of the system. So you have to decide how much management do you want to do. If you want to go high tech, you will go for for example, in vineyards, you will go for a drip system with fertigation and highly managed irrigation system. With we can speak about that maybe as well. But there are ways of managing your irrigation these days with technology that improves the efficiency greatly. If you are not willing to do intensive management, you should look at lower technology. And so I think the question is what technology is appropriate for both for the crop and also for you as a farmer to get the best yield that you can possibly get.
Thank you.
I think it is very important what he said. And we did some research on water use efficiency, and we developed a framework for South Africa that is linked to the international way of thinking. And we refer to as consumptive use and non-consumptive use. And within the consumptive use, we talk of beneficial use and non-beneficial use. And I think that is what Alfred said in terms of the right system for the right crop, utilizing the best technologies in designing it. And there's excellent technology in South Africa that can and are being used. So we are talking of the system applying the water correctly, and the crop that are utilizing that beneficial use should be optimized. Then there's the non-beneficial use. That is the one that you should decrease by means of evaporation or by means of weeds or by means of different aspects. Then the non-consumptive use is, of course, the water that you apply but is not being used by the crop or evaporation. That is the depercolation or runoff. If the center pivot has not been designed to apply the water correctly, you might have runoff. But the non-consumptive use is then two parts, the recoverable part and the non-recoverable part. And that's the international way of looking at irrigation systems. And the farmers are playing an excellent role in terms of monitoring what's happening in the soil with the probes that the companies are supplying to them to really minimize the non-consumptive use and maximize the beneficial consumptive use.
Thank you, Felix.
Sorry, to add on to what Felix and Alfred are also saying is that I guess no one can disagree that we have to do more with less. You know, I mean, in the next 30 years, we're going to add on another 10 million people into our population. By 2050, we're going to have 65 million people in South Africa. Technology is going to play that really important factor, and the farms are not getting bigger. You know, I mean, we're already having discussions where we have to put in more density, but where's that sort of optimal sort of economic curve? Speaking back to where Bruno was saying, is that it's not just about the practical applications on the ground, but where do we meet that social and economic benefits as well? Because what we're also finding is sometimes we're just throwing money at a problem, and we're not showing actually if it's yielding the exact results that we want. So technology is really kind of playing that key in the decision-making points, which we're finding in the irrigation space as well.
Yeah, that raises an interesting idea. You mentioned probes. What do you see the role of data and the gathering of data being in water management? Is it increasing? Is it becoming more efficient? Is there more data available? Could you perhaps, to the panel who wants to respond?
Well, I could respond.
Yeah.
There's the past couple of years a huge increase in utilizing, and one person once said, you only realize the worth of water when the well is dry, when there's no water. Then you start to make plans. But fortunately, there are many farmers that have made use of excellent equipment with that you can monitor what's happening in the soil profile. In the Western Cape, for instance, they have employed a satellite imagery where farmers can, in real time, see what is happening in their orchard by means of the data that's been interpreted by means of computer models, and then it's been displayed real time for them, how, when to apply water and how much. So there's increase countrywide in terms of how the farmers are really taking advantage of the technologies that are available, cell phone technology, different aspects, the pivots that Alfred talked about, how they are being managed in terms of the variable speed drives, the variable application rates. So many things are being utilized to optimize water usage.
And what, sorry, Bruno?
No. Yeah, just continuing on the same idea. Well, I think that this question of the big data is really entering agriculture since, I would say, 2 years. Yes. It's very recent, and of course, this is the future big challenge. But what to do with this data? And as I was saying about the overall approach that we try to have with technology, sociology, and economy, I think that if we want to have successful data use, we need to be able to organize this data together and to make this data dialogue together. And today, most of the technology that we have is dedicated to one aspect of the problem and not integrating other aspects. And that was that is our next future, is to how to make these different layers of information dialogue together. We have the soil layer, we have the crop layer, we have the irrigation technology layer, we have the meteorological layer, and we need to have this layer dialogue together to be sure that as when you turn the key of your car, you don't manage ignition or whatever. In this case, I think that this is the next step to address. So
no problem. Yeah, we're finding the same thing, that the technology is being, like you're saying, Bruno, is being developed in silos, which is great. I mean, you really are. I mean, like I was speaking to, like what Felix is saying, is that farmers are starting to become a lot more proactive. So we're doing, from a drone technology perspective, we're doing a lot of sort of that mapping and surveying, even before you get to the irrigation and the planting phase, to even start mapping and start doing sort of water forecasting, where your rainwater is going to collect, because you want to kind of minimize your energy usage. So a lot of research is done all in those particular silos, and I'm sure Tony will speak as well about on the ground, is saying how that's being interconnected. But we are seeing in the next couple of 3 years, I think that wave is going to break over, where we'll see us having that conversation. I guess it starts here as well.
I think on the data collection side, I think in agriculture there is a lot of data being collected. The challenge, and that being a challenge for me as a farmer, is how do I interface the data? How do I use that data to apply it to what I'm doing? And it needs to be done in a practical way that we can manage. You know, if it's too high level technology wise, it is great, but it could start actually blurring the image, too much data. So we need to look at how we're going to use it, how we're going to apply it. You know, we have various challenges on the people that operate the machines, and we've got to make it simple, easy, user-friendly. That's our biggest challenge, I think.
Tony, can you expand on the current challenges you're facing in terms of water management on your farm, and then what are the things we need to start doing today to better cope with future droughts?
Our challenges that we have in our operation, especially in the terms of irrigation, is the crops that we plant are relatively low-value crops, for instance, corn and soybeans. So in order for us to get the biggest bang for our buck, we need to get the most yield with the least input, thereby reducing water. Our other challenge that we have is that all our center pivot irrigation, we have variable soil types in each and every field. So now at end tower, last tower irrigation on your center pivot, at every different position that the pivot is, there's a different soil infiltration rate. So you need to be able to, the ideal would be variable irrigation on a center pivot. In that way, we will be able to reduce the amount of water applied to the crop to actually get the maximum yield. Now, the challenges that we face is how to irrigate and when to irrigate and how much to irrigate. That is one of our biggest challenges that we find in. Because of farmers, we are always very price sensitive, and we look at reducing costs. We do not always have a single pump per single pivot circle, so we share pumps among circles. So now you sort of press by time that you need to get through that circle. Whether the wind is blowing or the sun is shining, you need to do it, or else you're not going to get your millimeters down. So now we need to start looking at nozzle technology, is how do we get the right droplet size onto the plant. But together with that, then we're starting to get different diseases on different plants. For instance, on the soybeans, we suffer a lot with sclerotinia or white mold. And that is a factor of humidity, or one of the factors being humidity. So how do we manage that? So we need a lot of information on that. How do we manage drought situations? How much do we irrigate when the sun is, your ambient temperature is 40 degrees? Is it wise to irrigate? But all our irrigation is being designed over a 24-hour cycle, so you need to irrigate whether the sun is shining or not. So we need to learn how to manage that, and at what stage the plant is, at what growth level it is, what is the actual requirement of the water. And I find that sometimes we tend to over-irrigate, which has also a negative effect on our yields.
Alfred, could you perhaps expand on those issues that Tony has raised in terms of the timing in a 24-hour cycle? What are the thoughts around that, and how can we mitigate that?
Yes, I think the dilemma for the irrigation farmer at this stage is that we've got a lot of technology available, but like we said before, it's all in silos. So the farmer still has to make the decisions, interpret all the data that he has. I think in terms of irrigation systems, a lot of progress have been made to manage the system better and easier. So nowadays we control huge irrigation schemes on the internet. All the pivots are on one platform together with the pumps, with the VSDs. You can manage the pressure in the system. You can manage multiple pivots on multiple pump situation, dam level controls. We've got demonstrations like that on our stand here at Nampo, where we've got water pump from a river or a dam level control, booster pump for certain sectors in the area, and then we've got 3 pivots on there, and all of that managed on one internet platform. So it becomes a lot easier, but in the end, you have to start with the design. I mean, if you've got different soil types, it's cumbersome to afterwards try and fix an error by introducing expensive and cumbersome technology like variable irrigation rate, which the margin for error is small. I mean, if you've got a computer failure or a hardware failure, you can have huge losses. So it is better to design the system according to the surveys, the soil analysis, place the pivots in the correct positions so that you've got as uniform a field as you can have, and then many of the things you can deal with technology, like slopes and multiple machines on a system. You can optimize that today very easily. So once again, choose the technology that is appropriate for you, that you are capable to manage, and get the best result.
Going further of what you were speaking about, the quality of irrigation, the characteristic of irrigation, one of our research field is dedicated regarding sprinkling systems, is dedicated to the management or to the understanding of what happened in terms of droplet sizing, the way the jet is dispersing, and what is the result in terms of size of droplets and the consequences on the soil in terms of impacts, of course, but also on the losses by drift and evaporation connected to the size of the droplets. What we have identified from a PhD, which have been conducted now maybe 7 years ago, we know that all the droplets that are lower than 500 microns, more or less, are subjected to high evaporation loss because of their surface area. They have a large surface regarding the weight of water which is represented. And they are supposed to drift on a very long distance. And all the droplets which are higher than 2.53 millimeters are supposed to damage the soil, or maybe mainly to damage the soil. And so what we try to do in our research, and now for the close future in our testing activity, because we have a testing activity, let's say commercial testing activity, we try to figure out what could be the range of size of a machine that we could get to minimize the effect of drift and evaporation, for example, or soil silage due to impaction of droplets. And further, we could anticipate that we will be able, for example, to decide the size of droplets we want to have, given the question that we want to address. I illustrate. If you are, for example, seeding carrots or alfalfa with very small droplets, you need to have a very fine droplet applied if you don't want to destroy your seed bed. And on the other way, if you have a high level of wind, for example, during the middle of the day, you know that you have a high wind, so it's necessary to have bigger droplets, so decreasing the pressure, decreasing the velocity of the machine, for example. And so this is our ideal for the close future. And we are getting closer and closer to precision irrigation questions in the terms of management of the machine.
Just to add what both Tony and Bruno said, and Alfred, nowadays we talk about the water, energy, food nexus. And if you look at that concept, applying water through irrigation systems require energy, and therefore you must look especially at the amount of hours that you irrigate per day, and your design must be adapted. There are sort of peak times of tariffs that you would like to avoid. Therefore, the new approach is, of course, to make use of less hours, but then it will impact on the size of the pump unit, the size of the pipe, and research that was supported by the Water Research Commission, where they came out now with the life cycle of an irrigation system. The friction losses that you must minimize, and therefore also optimizing the energy that you're utilizing is of great importance. So the South African Irrigation Institute, together with our agricultural engineering of the ARC, are putting norms and standards out to assist the designers, first of all, that accommodate the requirements from the farming sector. And part of that is the testing of the irrigation equipment, that we also work together with the test laboratories in the world, which has been facilitated by France. They are the coordinator of that. And very important what Bruno said in terms of pressure, droplet size, and then of course what we refer to as the coefficient of uniformity. That is the evenness of the water being applied to the soil surface. That is of great importance for that crop that must receive the right amount of water at the right time. So if your norms and standards are correct, your design has been using the best technology and norms and specifications to provide the right equipment to the farmer, then you have looked from a technological point of view. But the farmer then played that very important role, and that is managing, because the system has been designed to cater for the peak water requirement in a specific planting season. So then he needs still to find out how much and when to apply that water to the surface.
And if I may add to that, the maintenance of the system.
Absolutely.
Because I think Felix did a study confirming that if you've got a 20% drop in uniformity, you've got a 40% drop in yield.
Yes.
And in most cases, the uniformity goes down because of the system not being maintained. Filtration systems failing, drippers being blocked up, sprinklers losing parts, not working correctly. And I think there is that's sort of the first step of managing your irrigation, is to maintain it correctly and make sure the uniformity is as it has been designed.
Okay. Chris, linking to the previous comments, you work with drones in agriculture. Could you perhaps give us an example of how a farmer can use drones to link to what Felix has said as well in terms of that management and how he can benefit?
So bouncing off Felix's last comment, I guess it's, the sword is only as effective as the one who swings it, So you can have all the great technology in the world, but if you're not managing it effectively, and coming back to Tony's, is saying, Tony's comment saying we have so much data coming in, how do we sort of culminate this into something that's useful, that's something that we can develop into practical solutions that we can get down to the ground. Now, drone technology, and what we're really specializing in is that we're really at the beginning, at the cusp of it, but the practical applications are coming really, really soon. We're finding that our main application right now in terms of drone technology is around about crop monitoring, so using NDVI matrices and monitoring the crops. Yes, there's spraying, yes, there's planting, yes, we feed into the precision agriculture sort of environment, the eco, and I believe the sort of Farm 2.0 is sort of, it's on its way. But what really the benefits of drone technology is the frequency of the data. And I always like to give this great example of, I don't know if you guys remember the days of Edge on your cell phones. You remember those days, right? We always used to have Edge before 3G and 4G and everything. And when we had Edge, we never really, we kind of used it. I don't know if you used, Felix, did you use Edge on your phone? I don't know if you, teasing. But when you had Edge on your phones, you didn't really use a lot of sort of applications. But once the smartphone came out, once we had 3G, 4G, even my mom now is on Facebook. Are you on Facebook, Felix? No. Not on Facebook yet. Okay. So we're finding that, as the speed of the data becomes sort of apparent and useful, thus we then develop the applications, or the more practical applications, into farming. So we're really in that middle cusp. But as drone technology, it's about the frequency. The more often we can collect data, the more information that we can, or more trend analysis we can do.
Thank you. Bruno, I want to ask a linked question. You do a lot of research around the use of grey water and recycling water. If you can give us a bit of an overview of the opportunities and challenges around that, and then I want to link it to the group in terms of the use of grey water in South Africa and some of the challenges, and also water quality in general. Is that a challenge?
Okay. So we entered this question of wastewater reuse, generally speaking, and I would speak about wastewater, not only about grey water. Grey water is only a part of the wastewater. And today I think that the main question is on wastewater, generally speaking, hopefully treated, but it is treated about at a rate of about, well, at least in Europe, it's about 70% of the water which is treated and the other is discharged in the environment. I don't know about South Africa. I know about Brazil, for example. Brazil collects 70% of its wastewater and treats among these 70% only 30%. So that means that most of the wastewater are discharged in the environment, which means that many of the farmers are reusing wastewater without knowing it. And a recent study by a geographer showed that this represents about 36,000 million hectares in the world. So 36,000, it's about 12% of the surface area which is receiving wastewater, treated for about 6 and not treated for about 30 million, which is huge. Then, so we came to this by the performance, through the performance canal, I would say. We were able to evaluate the performance of sprinkling system. I was speaking about fine droplets and runoff and so on. And so we entered in the wastewater reuse by this way. The question that we were asked by the Ministry of Agriculture, the ministry in France wanted to develop a regulation on wastewater reuse, and they were asking us what should we put as a limit in terms of irrigation technology or the characteristic of irrigation. So we valorized the work I was speaking about before on droplet sizing and requiring to undertake the characteristic of this droplet size. So I'm just a little confused. So the main challenge is the safety of this kind of practices. And if we want to address safety, we have two questions. The question of droplet drift. These droplets may carry with them viruses or pathogens. This is part of our research activity. We are working with people specialized in virus behavior, trying to see if the viruses are able to survive when they are applied to the plants, to survive whether they are on the plant and maybe inside the plant. So I cannot tell you more about that because this is one undergoing research. There is another aspect which is related to pathogen and bacteria, generally speaking. And so we know that many of the bacteria are not surviving to the distribution of water by sprinkling systems, for example. So it is another aspect on which we are working. In this case, we know a little more about the survival of these pathogens. We know that, for example, Salmonella or Legionella are pathogens that are surviving quite well to the treatment of even when they are dispersed in the air. The others are not, but we have to prove it. That means that part of our research activity is on this, proving that the current or the usual pathogens that are provoking disease, human disease, are not surviving on this kind of treatment. Well, I could speak about a lot about regrowth of pathogens in the pipes and so on, which is part of our activity. Then.
I could just mention, well, to my knowledge in South Africa, limited wastewater irrigation or grey water irrigation is taking place. Having said that, we got about 4,400 dams, spatially distributed all over South Africa, with our big dams, of course, on the Orange River. But a report was just released yesterday of the performance of our municipalities. And that is where wastewater is being, or grey water is being generated. And the outcome was, or the report was, that only 7% of our municipalities are performing to an acceptable level. So what that means is that also some of the waterworks, the purification works, is not operating properly. Therefore, you might find that some of that water land in our streams that impact on our farmers that is utilizing that water for irrigation purposes. So indirectly, they are utilizing grey water, but the water in South Africa is being regulated by the Water Act, Act 36 of 1998, that stipulates the quality of water. And it is also been monitored by the Department of Water and Sanitation. And our biggest schemes are along the Orange River, like the Fallards irrigation scheme with 36,000 hectares. Fairly excellent water that they utilize. But there are, of course, in some parts of South Africa, if we look at the Hartbeespoort irrigation scheme, where the water is coming from Johannesburg, main area, that water is of a very poor quality. And the farmers have to even purify that for certain crops. What Bruno was talking about, that they are really worried about the quality of the water, and that they are applying to their crops. That might influence, well, that it does influence. For instance, the whole tobacco industry below the Hartbeespoort Dam is non-existent anymore due to the chlorine, for instance, just in the water. Therefore, they have to plant other crops to sustain the production in those areas.
So part of the technology issue is managing water better, but then it seems managing water quality is going to be a bigger issue in the future as well, at the farm level.
So maybe just to mention, in the Western Cape, many of the towns have got already recycling the effluent water to farmers, so-called enriched water, which is being used with great success for farming. However, with drought now and water savings, I've heard a figure of 1/3. So all those farmers are getting 1/3 of the normal water because of less water coming through the waterworks. But with the emphasis on sufficient water supply for human consumption, the talks are that that water will be treated further in future to be able to reuse for human use, and so the farming use will decrease on that side.
Alfred, another question to you. It seems there's really a lot of technology out there and a lot of options. So it seems part of the challenge is also for the farmer to know which technology to go with. And then you also mentioned the maintenance and uniformity of filters and pumps. Could you perhaps give some pointers on that area in terms of making decisions of technology and how to manage that as part of a water strategy?
Yes, maybe what we had a discussion before we sat down about unique technology for South Africa, and I think that is interesting. I mean, irrigation is internationally it's more or less the same. It's the same science. The technology available is the same, but we have certain unique conditions in South Africa. For example, theft. In Europe or America, you will not lose your center pivots tires or the motors, the gearboxes, the cable. Over here, it's a reality, and Agrico has taken steps. So we offer technology to protect, with cable saver, wheel saver. We run the cable inside the irrigation pipe, so that it's not easy to steal. And that's that's sort of a unique technology available in South Africa alone, which should be considered. But in terms of the irrigation technology, I think there are many options for the farmer today, and I think you must consult with your irrigation designer, and before you implement an irrigation system, or if you want to upgrade it, look at all the options available and decide what is best for you.
Thank you. I think we can move to questions from the audience and get some views from the audience. Are there any questions?
Who gives it first?
No burning questions.
Maybe just to come back to the technologies, it's interesting to note that well, the whole world started with flood irrigation. From the earlier years, I had also the opportunity now to visit an irrigation system in China, which was built 256 BC. It's still operating. It irrigates 680,000 hectares, and it's mainly gravity irrigation. But if you look through the development over the years, where sprinkler irrigation came on the mark in the 1933s, where excellent technology was developed then, and what we see now. Then in the late 1950s, drip irrigation came about, although there was some experimentation and development way back in the 1800s. That dripper that we know today was discovered by Simca Blas and his son in 1959. It came onto the market in the early 60s. Same with center pivot. A farmer was actually the developer of a center pivot by Zyebach in the United States, where he put wheels and pipes and sprinklers together. And that was in 1949. So from there, the systems developed. And interesting enough, and not many people know that micro sprinklers as we know it today was developed in South Africa. Not for irrigation purpose, but for containing the dust on the mine heaps in Johannesburg. Because that dust blown into the households of the housewives, and therefore they were not very happy. So engineers sat down and they developed micro sprinklers as we know it today. So from there it went into the agricultural area. And today South Africa got the 4th largest amount of center pivots in the world. We got the 7th biggest area of drip irrigation in the world. And we got about the 8th largest amount of sprinkler irrigation in the world. Although we are only irrigating 1.3 million hectares, but our designers, our suppliers, and our farmers are doing an excellent job.
Yes. Panelists, I think our time is up. Thank you so much for your insights today. I think it's really an exciting time to be working in irrigation, and there's a lot of skills and new technology developing. So it's exciting times, and thank you very much.
Thank you very much.
Thank you.
Vriendskappe word gekoester wat gebou is oor dekades. Senwes, saam breek ons nuwe grond.